Hello, my name's Stephen Gorard. I'm going to talk to you today as part of my series on conducting education research. And the first topic today is about missing data. Um, so you'll find if you do research or if you read other people's research, that there will always be stuff that's missing from the data sets. It isn't always made clear by the people who are writing about the data sets, but you can have obviously missing cases, so cases that don't exist, where, for example, people have not responded perhaps to a survey or to a request for interviews. And you can also get missing values from cases that do exist, where people have responded to a questionnaire but not answered a particular question. And this is very common, and this is true whether you're using your own data or you're looking at secondary data that other people have already generated for you. But missing cases and missing data is almost universal. I've never seen a project that didn't have missing data. What I have seen, though, is projects that don't report it properly, which is perhaps the first lesson to learn. So obviously, why does it matter, missing data? Well, obviously, it reduces the number of cases. So you might set out to survey 800 students or 400 teachers, but if some of them don't respond or some of them respond but don't answer the proper questions, then you're missing some cases. You've got a smaller study than you wanted, and that's a shame. But more importantly, you're going to have bias in your results, because the people who don't respond are not some kind of random subset of the people who could respond. There'll be reasons why, in terms of maybe their literacy, their confidence, the amount of leisure time they have, their knowledge of the subject or their interest in the subject that you're asking them about. And that then affects the nature of the people who do stay in the project. So it's not random. There are proven differences where people have checked who has and hasn't taken part in studies. It's absolutely clear that the group that have not taken part are not the same and some random sense of the others. It also means, of course, that if you do a study, even if you try to have a random sample or to randomize cases to groups, like in an experiment, you'll end up not having random cases, because as soon as any of them drop out or don't answer questions, then it's no longer random. And this bias can be really important. It could affect the nature of your results. So what are we going to do? Well, first of all, plan the study to try and prevent missing data. Try and make sure that everybody you contact joins in. Try and chase up anybody who's missing data. So, for example, if you were doing an experiment and some of the people didn't give you their second maths test or whatever was needed for the design, then try and follow up, find out what happened to them. Were they ill? Have they moved schools? Now, we've done that routinely, where we write to schools where someone's moved and say, oh, this child was part of a bigger study. Can we ask them to do a test at your new school? Things like that. I think each case is valuable. It's like gold dust. So you should treasure all of the cases in your study and try and get as much as you can. You're never going to achieve it completely, but make the research exciting. Don't make the whole process a bureaucratic one. Make the first questions in your questionnaires interesting and exciting, and so on. Consider the literacy and the visual acuity of the people who might be responding to, or their hearing issues, and take account of that so that those people who might otherwise be marginalized from your research are able to take part. Because again, otherwise you're going to bias the results. But what you're going to do, you're still going to get some missing data, some missing cases. So the first thing, of course, is to record it. And the second step is to report that. I'm always suspicious of studies that don't report the missing data, or at least something like the response rate or something like that. Try and record when people dropped out, if they drop out, and why. It matters, for example, if you're doing an experiment, if the people agree to take part and then drop out before you randomize them to either a treatment or not a treatment group, then that's less important than if they drop out after they've been randomized. And it's important to know whether they were randomized to the experiment or to the control group. Sometimes people can get disillusioned. They agreed to take part and to be randomized, thinking they could be in the experimental group and receive some exciting new treatment. And when they're told they haven't, they may drop out. Again, that's going to bias your estimate of what the result is. You could summarize the hemorrhaging of your cases in a flowchart. start with the number that you contacted, the number who responded, the number who dropped out, the number who didn't answer particular questions, and so on. And that makes it very clear for the reader. But it doesn't have to be a flowchart, just however you want to do it. More important, report what you do know about the cases that are missing. So if you were contacting more participants than responded, what do you know about the participants who you contacted but said, no, I'm not taking part, or never replied to your request for information or anything like that? It may be limited, but you can tell us something. Did they live in the north or the south? Were they in the more educated group or the less educated group? With something like a longitudinal study or an experiment, where you're following people over time and some people will drop out, move school, whatever, fall ill, you may have some data about them, but not all of it. So again, in an experiment, you might test the students at the beginning of the experiment and again at the end. So if they drop out at the end, you can't use them in the experimental data. You can report what their previous tests were and begin to see, was it the case that, say, high retaining students dropped out or low retaining students dropped out, or more boys or more girls, or whatever you know about them, tell us about that. So you could also do a kind of sensitivity test where you could ask, well, imagine if the cases that I don't know about answered my questions or had characteristics or whatever, or tested a score that was inconvenient for my findings. I mean, just to take an example where you did an experiment and you had a group that was taught maths differently and then tested, and another group that was taught maths in the standard way and then tested. And the group that had the new maths approach tested with higher average scores than the other group. But you got missing data. So imagine that if the cases that were missing in the treatment group who had the new maths approach, imagine they had low scores, or that the group that were not the cases not in that group who didn't receive the new treatment had higher than average scores, so that the difference between your groups would actually reduce. And try and imagine whether by themselves the missing cases could actually destroy your findings, make them simply disappear. And one simple way of doing that is to take the effect size you get. I'll explain effect sizes in another talk. Take the effect size you get and multiply it by the number of cases in the smallest group. And that would tell you how many sort of extreme counterfactual cases would be needed to destroy your findings. And if the number of missing cases is clearly below that, then your research is relatively safe. And if the number of missing cases is clearly higher than the number of cases that would be needed to destroy your finding, then you've got a problem. Either way, you need to report it. But a sensitivity test, and that's not the only one, there are many of these out there, to see how sensitive is the finding to the missing data. Do not, and I really recommend you don't do this, don't replace the missing cases or the missing data with, try and adjust them with weights. I'm not going to explain weights, but you'll find them in the literature where people weight the responses because they haven't got enough of responses from a particular category. So they effectively multiply or boost the cases or responses from some cases to make up for the fact they don't have enough. And some people use complex multiple imputation to work out what they think the missing cases data would have been if they had taken part. And in both examples, what you're doing is using the data you have to try and overcome the bias caused by the data you don't have. And if you think of it like that, you can see it's actually just as likely to increase the bias in your findings as it is to overcome it. It looks sophisticated, it looks tempting. It does increase the number of cases because you're overcoming your missing data problem, apparently. But what you're doing really is taking what people who did take part told you and multiplying it in such a way that you think it will tell you what the people who didn't take part have told you. And as I've explained, the people who didn't take part will have a reason for it. They'll be different in respects. And therefore, you cannot assume that these methods work. So I would suggest you strongly don't do that. And you kind of ignore them when you come across them anywhere else. So what can you do? Well, here's two simple things you could do. One is where you have categorical data, you've asked a yes/no question, for example, then just keep missing as a category. So instead of having, what's the question, did you attend school today? Yes or no. You have yes or no, or did not answer for whatever reason. Now, the beauty of that is that it doesn't disturb the data. You're not distorting anything. You're not making any assumptions. You can keep all the cases in your study. And of course, you can and then analyze missing as a genuine category. And when I've done that in certain studies, I've found some really interesting results. For example, I had a paper that made the news, TV news headlines and so on, where the children we didn't know if they were eligible for a free school meal, that is, whether they were living in poverty or not, because the school records didn't show it, were actually more disadvantaged than the people who were eligible for a free school meal. And they had lower attainment outcomes and so on, many of them for traveller families and so on. So keep the missing and analyze it as a key value in your final results. And even if the data is not categorical, you can create a variable, is the data missing or not, or is the data present or not, for each case, and use that in your analysis. Once you've done that, for numeric variables, where you're simply missing something, what was your score in this maths test, you could simply give each case the average score of all the cases you actually have scores for. And what that does, it means that the overall average of the scores won't change. You can retain the cases, and therefore you might be able to tell something about them, so on. So it doesn't disturb your findings, but you should be aware that what you're going to do is reduce the variation, because you give every case that's missing data, and you have a few of them, then each one of them will have the same value. So you'll reduce what's called the variation or the variance, and that'll be expressed in, for example, the standard deviation, if you calculate the mean and standard deviation. So if you're going to use the standard deviation for something like calculating an effect size, use the standard deviation for the complete cases, the cases you've actually got values for, because that'll be a better estimate of what the standard deviation should be than if you use the slightly flattened, weaker standard deviation for all the cases where you've put in an average score. But, and this is a really big important but, do not do this if you've got a lot of missing cases or a lot of missing variables. There comes a time where you just have to concede that perhaps this variable cannot be used. And if you asked 1,000 people what their income is, and only 27 people have told you what their income is, I don't think you can use the variable. I would just throw it away or discard it from your analysis. In a really extreme case, you might have to simply say, I think this research has not worked. I haven't got enough data for it. I think that's very extreme. In most cases, if you've got a little bit of missing data or a few missing cases, it might be legitimate for you to make these assumptions by treating what's missing as a genuine category and or giving them an average score so that they don't disturb the differences between boys and girls or whatever, but you can use them for other purposes. Whatever you do, you've got to take the amount of missing cases into account when you are drawing your conclusions from your research. So there are many, many reasons why we want to be humble and tentative when we draw conclusions from research, not just because of missing data, but missing data is a key factor. So if you know there's stuff missing, don't hide it, report it, analyze it as far as possible, include the cases as far as possible, and then explain when you do your results that you're going to be a little bit more cautious about what you're going to claim because you've got missing data. And it seems to me that's the honest, ethical way to do research. And it's a really simple way to handle missing data. And I hope that helps.